This section is going to have us looking at some applications of right triangles. How do we solve a right triangle? Well, we've pretty much looked at a lot of this before. We're just kind of putting it all together. To solve a right triangle, you might be giving an angle and a side or two sides or something like that. And when it says to solve it, that means to find the remaining angles and the remaining sides. So example 1 says that angle A is 62.7 degrees and side A is 8.4 units. Solve the right triangle, rounding to 2 decimal places. Okay? Well, let's start by finding the hypotenuse. We know that sine is equal to opposite over hypotenuse. So we're just using what we have. We have an angle, we have the opposite to find our other values. We could have found B first and used tangent. It really doesn't matter. We could have found angle B first by subtracting 62.7 from 90. Just depends on what you choose to do first. It really doesn't matter. So multiply both sides by C. And this will require us to divide by sine of 62.7 degrees. And all you have to do is put that in your calculator. Just make sure that your mode is in degrees. And we get that the hypotenuse is 9.45 units. Let's move on and find angle B. Well, since angle C is 90 degrees, then that means we can find the measure of angle B just by subtracting 62.7 from 90. Gives us 27.3 degrees. And last, we just need to find B. We can do that, or side B. We can do that by using tangent. We could use cosine. I'm just going to use the Pythagorean theorem. It's totally up to you. We've got the hypotenuse squared equals our side A squared plus B squared. So B will be the square root of 9.45 squared minus 8.4 squared, which is the square root of 18.745, which is approximately 4.33. And now we have solved our right triangle because we found all the other angles and sides. Example 2 says, from a point level on the ground, 80 feet from the base of the Eiffel Tower, the angle of elevation is 85.4 degrees. Approximate the height of the Eiffel Tower to the nearest foot. So we're going to be talking about, did I not put that in here? No, that's okay. Angle of elevation and depression. Angle of elevation is just going up for the horizontal. Angle of depression is the angle going down from the horizontal. So we've already got our picture here. It says the angle from the horizontal looking up to the top of our tower is 85.4 degrees. And this person is standing 80 feet from the base of the tower. And we want to know the height. So what we've got here is we've got a right triangle with an angle. We're wanting to know the opposite side. We've got the adjacent side. That means we're going to use tangent. So opposite over adjacent. A will be 80 times the tangent of 85.4 degrees. Just put it in your calculator, making sure your mode is in degrees, and we can say to the nearest foot that the Eiffel Tower must be 994 feet tall. Another similar example says a guy wire is 13.8 yards long and is attached from the ground to a pole that is 6.7 yards above the ground. So I guess a guide wire is kind of like some kind of support for this pole. Not really positive. That's my guess. So we've got this pole here, and it's 6.7 yards tall, or at least the wire is attached 6.7 yards from the ground. And we've got the length of the wire, and it says, find the angle to the nearest tenth of a degree that the guy wire makes with the ground. So here's our guy wire. We want to find the angle it makes with the ground right here. So we'll call that theta. So according to theta, we've got opposite over hypotenuse. That means we're going to use sine. So use your inverse sine in your calculator and just put that in. And we get that theta is approximately 29 degrees. The other thing we need to look at in this section is bearings. So bearings are used in navigation and surveying. And the bearing from point O to point P is the acute angle measured in degrees between ray OP and a north-south line. This will be easier if we look at a picture. Here we go. So your bearing is always measured. If we've got point P here, it's always measured from the north-south, so from the vertical to the terminal side of the angle that goes through the point. There we go. So we always say north or south first. So this point is at north, 40 degrees east. So we say north or south first, then that angle that it makes with the vertical, and then our west or east, depending on where it is. So like this one here, we've got, it's 70 degrees from our vertical line. So we say it's south because it's down below the X or horizontal axis. We say it's south 70 degrees east. So example 4 says, use the figure to find, first of all, the bearing from O to D. So O to D is this angle here. So this is pretty simple. We just start with south because it's going south. 25 degrees because that is the angle between the vertical and point D. And then it's heading towards the east, so we put east. And that's it. Part B wants the bearing from O to C. So that's this angle. Now this one's a little bit different because we don't have this angle here. But we can find it, okay? We've got a right angle where this is 75, so we can find this angle just by subtracting. So 90 minus 75 is 15. So this angle is 15. And now we've got all we need to know. So the bearing is south, 15 degrees west. Let's look at an application of bearings. It says a Boeing 777 aircraft takes off from Nashville International Airport on runway 2 left, which has a bearing of north 20 degrees east. After flying for 1 mile, the pilot of the aircraft requests permission to turn 90 degrees and head towards the northwest. The request is granted. After the plane goes 2 miles in this direction, what bearing should the control tower use to locate the aircraft? So we've got a picture, but sometimes you're going to have these problems, and it might not give you a picture. So let's talk about how we might draw this. First off, it says it takes off from the airport. So we're assuming the airport is right there in the middle, okay? And it takes off at a bearing of north 20 degrees east. So it's going 20 degrees from the north towards the east. So something like that. And it flies for 1 mile. It says then the pilot wants to turn 90 degrees. So we're just going to, from this point where it's gone 1 mile, we're going to turn 90 degrees. And head towards the northwest. So, yeah, how did we know we weren't going this direction? Because we were going northwest instead of, I guess that would be southeast. So, and it says that it goes 2 miles in that direction. So what we need then is, where is this point now? So I'm just going to use this picture that we've drawn, and let's see what we can get from this. So we need to know then this angle here. Well, it's not an easy way to find that angle straight off, but what we can do is we could find, trying to find me a different color here, the measure of this angle, right? And then we've got this one right here and subtract off. The reason I say we can find the measure of that angle is because that is our right triangle there, where we've got this side is 1 and this side is 2. So we can use tangent, we'll call that theta, that's opposite over adjacent, to find the measure of that angle. So we're finding the inverse tangent of 2. And so this angle is 63.4349 degrees. Now that we've found that angle, then we can find our smaller one, the little red one there. So I'm going to call it alpha. We've got 90 minus, not 90, we've got 63.4349 minus that 20 degrees. So that is 43.4349 degrees. And let's see, did it tell us how far to go? We're just going to go to 2 decimal places. So that means our point of our airplane now, I can't really draw an airplane, there we go, is north 43.43 degrees in the west direction. And that concludes this section.